Hi, my name is Safi Khan and I'm a Regional Product Marketing Director at Telit. Welcome to this edition of the Telit Coffee Connection series. Today I will be covering the top 3 end-to-end factors impacting Gigabit LTE uplink performance. In the modern Gigabit LTE networks today, higher uplink speeds are becoming a necessity. There is an explosion of data usage, both in the downlink and the uplink directions, because of so many use cases that I can't cover all of them in this short talk. Just to cover some of them that focus on uplink performance, let me list them so you will know what I'm talking about. The first one is LTE branch office networking, in which LTE offers an inexpensive and efficient solution for business branch offices. These offices make heavy use of video conferencing, so they need fast uplink speeds so that they can have a smooth video call with their clients. Other examples or use cases are connected video cameras. They are proliferating at a very high rate, especially because of working from home. Similarly, the use of cloud computing, file storage, backup, synchronizing with the corporate network, etc. These are all use cases where uplink performance is very important. There are so many more use cases, but I will stop here to talk about the fundamental factors that make this fast uplink possible in LTE networks. So there are 3 main factors that impact gigabit LTE performance. The number 1 factor is higher order modulation. The second one is the use of MIMO, MIMO, which stands for multiple input, multiple output. And the third is carrier aggregation. So let me explain each of these in more detail. The first factor is higher order modulation, and it is a scheme in digital communications that allows more efficient encoding of information before transmitting it over the air. Basically, it works by packing more bits of information into a packet, more data that the modem sends over the air. So as an example, you can think of a truck on a highway, and the higher order modulation means packing more stuff into the truck without taking more space on the highway. So you are able to carry a bigger load or more stuff in the truck. So using that example, when in gigabit LTE networks, in the downlink, you can use up to 256 QAM, which is the measure of the modulation order, 256 QAM modulation. And in the uplink speed, which is from the device to the network, you are able to use up to 64 QAM QAM modulation. So let me explain what these numbers mean. These numbers represent the order of modulation. The higher the number, the higher the order and more bits you can pack, or more densely everything is packed inside. Specifically in the uplink, the latest LTE standard allows for upgrading the modulation scheme from 16 QAM to 64 QAM, which means that instead of packing 4 bits per symbol, you can pack up to 6 bits per symbol, because these are all powers of 2. So 2 to the 4 is 16, and 2 raised to the power of 6 is 64. So in gigabit LTE networks, you are able to do 64 QAM modulation, which means instead of 4, you can pack 6 bits of information per packet. So you're basically adding 50% more capacity, but it depends on some other factors to get a net overall benefit in increase in performance. So that was the first factor in gigabit LTE performance. Let's look at the second factor. The second factor is called MIMO, and it stands for multiple input, multiple output, as I said. This basically means using two or more antennas instead of one to send information from the transmitter to the receiver. Again, this is a concept in digital communications where the use of more than one antenna helps the modem to transmit two or three or four copies of the same data or send two, three, or four streams of different data using different antennas from the transmit to the receive. And in the case that the signal suffers any degradation during its journey in the air from the transmitter to the receiver, it could suffer fading or interference, and so the bits could change. And the modem on the receiving side can receive those multiple copies using multiple antennas at the receiver as well, and recover the original signal with a much higher probability. So your performance increases because you are using spatial diversity, spatial multiplexing, and basically transmitting signals over multiple antennas which are separated from each other. And so that gives them an extra boost in performance. In gigabit LTE networks, up to 4 by 4 MIMO is used to increase the network performance. The third factor that impacts gigabit LTE performance is carrier aggregation. This means the aggregation of multiple radio channels, also called carriers, that are chunks of radio spectrum, often non-contiguous with each other, that enables the operators to increase the data rates with the spectrum they have available. Each carrier of spectrum is a path that has an upper limit on how much data it can transmit. So when a modem can combine two such carriers, it can essentially double its capacity because it is adding extra paths between the transmitter and the receiver. In gigabit LTE networks, it is common to deploy two carrier aggregation in the uplink to achieve 150 megabits per second. There are two types of carrier aggregation, which from now on I'll call CA. One is called intra-band and the other is called interband. So intra-band carrier aggregation combines carriers from the same frequency band. So one frequency band can have aggregation of carriers which are close to each other in the same frequency band. And this scheme can be used when an operator owns a lot of spectrum in the same frequency band, but that's not very common. It's rare. The second type of aggregation is called interband. So now you can have separate bands in two separate frequency bands, and then the modem can basically combine them into two carrier aggregation, but by tuning the frequency simultaneously to do two different RF bands requires extra hardware in the modem or the module. This is more typical of operators because they have spectrum which is spread around. It's not contiguous. And so they like this feature because this allows inter band to be possible and make use of that to achieve higher performance. For this interband CA feature to be implemented in an LTE modem data card like the Telit LM960A18, as I said, it has to have those two independent RF data paths that can simultaneously tune to two different frequency bands. So the LM960A18 Gigabit LTE data card from Telit is the only 4G module in the market today that can actually support interband carrier aggregation or uplink CA to achieve 150 megabits per second. Our FN980 series of 5G data cards can also support interband uplink carrier aggregation. So I hope that you enjoyed this little talk. Let me summarize the three factors that affect gigabit LTE performance. Number one, higher order modulation. Number two, the use of MIMO antennas. And number three is carrier aggregation. So with these factors, you get gigabit LTE speeds. And I hope that you enjoyed that quick review of these factors in gigabit uplink LTE performance. If you want to learn more, please feel free to schedule a meeting with us. Thanks for joining today.